faculty members, and dear participants present online in this plenary session 2 of Avdharan 2023. We feel privileged with the gracious presence of Session Chair, Dr. Santosh Dhar, Dean Faculty of Doctoral Study and Research, SVV, and Dr. Saurabh Jain, Professor of Computer Application, SVV. It gives me immense pleasure and I feel honored to introduce the eminent personality, the conference session chair, Dr. Santosh Dhar. Dr. Santosh Dhar is Dean Faculty of Doctoral Study and Research at SVV. Dr. Santosh Dhar has been engaged in teaching, research, corporate training, and consultancy for the last 42 years. She has more than 394 publications to her credit. Under her supervision, many research scholars have been awarded PhD degree. Her earlier important assignments are Professor at Amity University, Noida, Professor and Dean, J.K. Lakshmipati University, Jaipur, Professor in HR, Jaipuria Institute of Management, Jaipur, Professor and Chairperson HR Institute of Management, Nirma University. She has also worked at IIM Kolkata, NMICA, Ahmedabad. Dr. Santosh Dhar has designed and conducted management development program for the executive of several business houses such as Grasim Industry, JK Tyre, Bridgestone, Hindustan Motor, ONGC, and many others. She has been in the panel of reviewer of Oxford University Press and Tata McGrath-Hill. She was managing editor of Prestige Journal of Management and Research and Prestige Research Abstract. It's an honor and privilege for me to introduce the second session chair, Dr. Saurabh Jain. Dr. Saurabh Jain, Professor of Computer Application, Head of Center of Excellence in Data Science. Currently, he is also heading Sri Vaishnav Institute of Law and coordinating and communicating about the law School of Law in the university. He has more than 17 years of teaching experience and research experience. He has published more than 50 research papers. He has also coordinated many national level activities and competition at SVV. Dr. Saurabh Jain also guided many PhD research scholars. Now, I would like to invite Honorable Session Chair, Dr. Santosh Dhar, Dean Faculty of Doctoral Study and Research, for the opening remark. Over to you, ma'am.
Okay, thank you. Esteemed resource persons for the session, my co-chair, Dr. Saurabh Jain, other dignitaries, participants, a warm welcome to the second plenary session of Avdharan 2023. In recent years, we have witnessed the emergence of intelligent computing, a new computing paradigm that is reshaping traditional computing and promoting digital revolution in the era of big data, artificial intelligence, and Internet of Things, with new computing theories, architectures, methods, systems, and applications. Intelligent computing has greatly broadened scope of computing, extending it from traditional computing on data to increasing diverse computing paradigms such as perceptual intelligence, cognitive intelligence, autonomous intelligence, and human-computer fusion intelligence. Intelligence and computing have undergone paths of different evolution and development for a long time, but have become increasingly intertwined in recent years. Intelligent computing is not only intelligence-oriented, but also intelligence-driven. Such cross-fertilization has prompted the emergence and rapid advancement of intelligent computing. Intelligent computing is still in its infancy, and an abundance of innovations in the theories, systems, and applications of intelligent computing is expected to occur soon. The technological fusion of intelligence and computing, important applications, challenges, and future perspectives can cast valuable insights into the intelligent computing for academic and industrial researchers and practitioners. Today, we have eminent experts who will be giving us deeper insights into the subject. And by the end of the day, we'll be more knowledgeable about the subject. Thank you so much. Over to our anchor.
Thank you very much, ma'am, for enlightening us with your wisdom of knowledge. Knowledge is the eye of desire and can become the pilot of soul. Intelligent interaction and knowledge recipe has greatly broadened the scope of computing. Now, moving further in this plenary session 2 of Avdharan 2023, it gives me immense pleasure to introduce our first speaker of the session, Mr. Mohit Patiala. Mr. Mohit Patiala, presently working as a customer engineer in Google at Pune, Maharashtra. Mr. Patiala has 18 plus years of industry experience and have worked in various verticals like education, banking, manufacturing, and government. He is currently associated with Google as a Google Cloud Customer Engineer, where he worked with the education and education technology companies and institutes to understand their business needs and goals. And he designed and implements solutions that meet their needs. He has also worked as a solution architect with Red Hat, where he handled responsibility for leading the pre-sales engagement in the Indian subcontinent. He has rich knowledge of cloud service and architecture. Now, I will request Mr. Mohit Patiala to share his knowledge with us.
Thank you, ma'am, for that introduction. And let me start with thanking the Avdharan team to give me this opportunity to speak about cloud computing today. And let me start with greeting the respected personalities, the teachers and the students. Good morning and a warm welcome to all. I'll just share my screen and please let me know if you're able to view it properly, and then we can start. Am I audible, ma'am? And are you able to see my screen?
Yes, sir.
Okay. Okay. So I hope my screen is up. So let's talk about. I had a very generic topic in mind today, rather than giving a lot of deep technical insights, information. What I wanted to leave you all today is with a high level understanding of how computing has evolved over a period of time, and what is the current state, and what is the social impact of those changes that are happening today, right? So the topic is evolution of computing, and if you see on the right hand side, right, as humans have evolved over a period of time, computing has also evolved, but the pace at which computing is evolving is far faster and superior than the human evolution, right? And I actually was looking at what advanced computing, which is basically the topic of today's discussion, right? So as per the definition, right, which I could find on the internet, right, advanced computing is the usage of high performance computing, quantum computing, cloud computing. Ma'am did talk about edge computing, all of these technologies to solve complex problems, right? And problems could be in various fields. It could be in healthcare, engineering, space, finance, etc. Now, before I talk about technology and cloud computing, I just wanted to reflect upon a fact, which is the Indian startup ecosystem. Because in my current role, I work with a lot of startups, and what you see are the stats on the screen, and some of the stats may be staggering to you. That I'm not sure how many of you know, but India is today we have the third largest number of unicorns in the world. Only after US and China. And a unicorn is basically a startup which has a valuation of $1 billion. And if you see the number of startups that have come up in the recent years, so in 2019 we had 7 unicorns from India. In 2020 there are 11 unicorns from India, and in 2021 there were actually 44 unicorns from India.
Entered the classroom and asked his students to prepare for a surprise test. They waited anxiously at their desks for the test to begin. The professor handed out the question paper with the text facing down as usual. Once he handed them all out, he asked his students to turn the page and begin.
Please mute
To
yourself.
everyone's surprise, there were no
Let me tell
questions,
some
just a black
background
dot in
noise.
the center of the page. The professor,
Please
seeing the
unmute
expression
yourself.
on everyone's face, told them the following. I want you to write what you see there. The confused students got started on the inexplicable task.
Okay. Sorry for that
Sorry.
technical glitch. No worries. So let me start from where I was, right? So I hope my screen is up again. So this is a very staggering fact in terms of how startups are evolving in India, right? And for startups or any company to grow, right, there are two things I think fundamentally which are required. One is an idea, which is like which is very apt to what our session today is, Avdharan, kind of an idea. And then how do you execute that idea? Now, execution of the idea has a lot of things, right? You need to have a very unique idea which you think can help build that next billion-dollar company. But what you also need is a way to seamlessly execute that idea, right? And one of the important aspects of executing that idea is technology. So all of these unicorn, I think most of them, one thing they would have in common is they would be relying on technology to a great extent to become what they have become, right? And so what cloud computing plays an important part is, and if there is one thing I want you to take away from today's session is these advanced technologies or advanced computing technologies have uh, reduced the entry barrier for anybody to compete with large enterprises. And it has kind of democratized that market where anybody with a good idea can compete with the largest of the companies in the world. And that brings me to my first point, again, keeping the theme of evolution. So how do you procure infrastructure as a company? Now you have an idea. Now you want to execute that idea and you want to run that idea through some technology. How you used to do it before is everything was running in the data centers on-prem, right? Which is, we typically call it on-prem infrastructure, which is like, I'm not sure if anybody has seen it, but there are large data centers if you go to these companies, right? Which will have, which typically looks like the left, right? Where there'll be racks of servers and networking and storage and whatnot, right? To power those. These are very, very expensive. But as we evolved, right, that was the only way to procure hardware in the earlier days, right? But as we evolved, we moved to something called as co-locations or colos, where you don't need large infrastructure. Rather, you can rent infrastructure from different companies which have these capacity available, and you can rent it on a monthly basis. But again, still it was a paperwork. You had to talk to the companies. You allowed to give them money upfront. There was a contract, but what the further evolution is cloud, where you do not need to do anything. You just can go sign up for one of these hypervisors, including Google Cloud. Just provide your credit card, and then you're good to go. You can spin up machines and do whatever you want. So a typical analogy I like to give here is how you use I mean, if you see 20-25 years from now, right? If you wanted to ride a car, the only way to ride a car was you need to buy a car, which was the traditional way of on-prem procuring, right? Now, 5 years from now, or 10, let's say 10 years from now, in 2050, 2005, 2010 timeframe, right? There was an option that you can call your neighborhood bhaiya and then a driver who might have a car and rent it for a day. That is more like colo. And now the latest way is Ola and Uber, where you do not need, you need it on the fly. You just go to your Ola and Uber app, you book the cab. So this is how your experience on the cloud has also been. So moving from on-prem to colo to cloud is like moving from owning a car to booking a cab on Ola, right? So basically, you don't need any upfront investment, and you can get not infinite, but in absolute terms, but infinite capacity, so to speak. Now, essentially, what cloud is, right? It is a bunch of services. So you must have. So Google Cloud is there. Amazon actually calls its cloud Amazon Web Service, right? Or web services. Which is kind of a cumulation of services that they offer. And primarily, any cloud, the services will fall only into three broad buckets, which is compute, network, and storage. That is all you need. And obviously some management tools around it. So compute is how you procure compute and run your solutions, right? Compute, say, like the virtual power that you need, the Intel or an AMD processor, that is compute. Storage is where you will store your data. The data could be locally stored or it could be stored in a database, right? And networking is how do you plumb or do the plumbing of these things, right? So that is essentially what a cloud is. Cloud provides you services which are primarily only categorized into three broad buckets: compute, storage, and networking, and some peripheral systems around that, which is like management tools, so on and so forth. But then you must be wondering why then we have so many services. Amazon, I think at this point is more than 200 services. Google would have more than 100, 150 services. So every cloud hypervisor has so many services. Now you must be wondering that if the broad bucket is only compute, storage, and networking, why would we have so many services? So the reason we have so many services is something called as the ease of use, how you want to use those services, right? Again, let's go back to our same example of Ola and Uber, right? Now you have Ola and Uber, but in Ola and Uber also you have different options, right? You can book a cab, you can book a large a sedan, a hatchback, auto. You can also book a bike now, Rapido, right? Also, you have an option whether you can go for Ola, which is like somebody is driving you, a chauffeur-driven car, or you have an option to do a self-driven car, right? Which like Zoom, right? Sorry, Zoom car. If you have known about Zoom car, you can rent a car, but you can drive. You don't have a driver. So the whole idea here is you have choices. So although I say that the broad category of services fall into these categories, you have choices of compute, whether you want to run compute only as an infrastructure, or you want advanced services where you want a platform as a service or a software as a service. And I'll talk about what these are. But ultimately, it's all about choice. Choice in compute, choice in network, choice in data. That is what it is. And what this choice, in simple term research, is referring to is infrastructure as a service, platform as a service, and software as a service. I'm sure you must have heard about these names, but what it essentially means is on-prem, right? Again, so same car analogy, right? In the past, you own a car, you own everything, right? You have to fuel the car, you have to do the maintenance of the car, you have to do the cleaning of the car. So basically, from the entire stack, so from the networking to storage to server to the operating system to the runtime to your application, everything you are owning. So basically, the green color means what you are responsible for, and the orange color means what the cloud provider is responsible for. So obviously in on-prem there is no cloud provider. You have to do everything, and it used to take weeks, if not months, to set up these systems. In cloud, right, there is an option that you can procure a simple VM and say, I want to procure a VM, I will manage everything else. So basically you can say, I just need virtualization layer. I want to manage what operating system I will install on that software, what runtime I want to use, and what application I want to run. So this is typically called infrastructure as a service. Now, what it gives you is more control. So you have more control around which operating system you are installing, what runtime you are running, what applications you are running. So you get more control, but what you are losing in is self-service. So it's kind of a knob. So and one end of the knob, it is like whether you want control, and the other end is ease of use, and you can just keep on switching the knob to your need. Now in platform as a service, what happens is the cloud provider actually owns more of that, right? So so basically from the virtualization layer, now even the operating system and runtime is being managed by the cloud provider, and for you just manage your data and your application. And software as a service is everything is managed by the cloud provider or whoever is providing that service, and you just use that service. You don't know what language it is written as, what is the technology it is running behind. You are not bothered about it. You just pay for that service, or in some cases it might be completely free. So for example, email is a software as a service. If you are running a compute instance on the cloud, it is infrastructure as a service. If you are running Kubernetes, if you have heard about this concept of containers, right, and Kubernetes, if you are running those services on the cloud, it is classified into platform as service. Now, we talked about how we evolved in terms of how we procure infrastructure, right, and how you build your app. So how you build your application also has evolved, not just the procuring of the infrastructure, right? So how you used to deploy applications in the past is, you need to deploy an application. You You buy an hardware, you install an operating system, and then you run your applications on top of this. The problem with this system was there is no segregation. There is a single box which is having your application, operating system, and all your applications are running on top of it. So that if that box goes down, everything goes down. And the other issue with this architecture on the left was, let's say you have different applications. Some applications only run on Linux, some run only on Windows, or you have some specific needs around operating systems or vCPUs. You cannot do that because you are fixed with an operating system and hardware, and you have to run your applications on top of it. It's like your laptop. Now, what happened over a period of time? There was a concept of virtualization. So you must have heard about this company called VMware, which is a leader in the virtualization space. So what they did is, same hardware, they have a base operating system. They have another layer called the hypervisor layer, which will sit on top of the operating system, and then you create your own different virtual machines. So it's like on my laptop, which is a Windows laptop, I can have a virtualization layer or hypervisor layer, and I can also run Linux on top of it as a separate VM. So I can have a Windows VM, I can have a Linux VM, and I can manage them separately. What it gives is basically you can have some kind of segregation between your applications, but it also had a drawback. Every application required its own operating system, and operating systems are not, so basically are compute intensive, I should say. So they take a lot of RAM, there is a lot of compute, storage. So there is a lot of operational overhead. So basically, if your application requires 2 cores, it is possible that your operating system also requires 2 cores. So instead of using a 2-core machine, you will have to create a 4-core virtual machine. So this was better than the traditional deployment, but it also had certain drawbacks, right? So that is where containers came into the picture. There was a company called Docker, which initially bought this concept based on Linux kernel, right? Where what they say is, you have a layer. So instead of on top of the operating system, don't have hypervisor, but have actually something called as container runtime. And on top of it, you create your packages, containers and applications. These are like your packages, like you create your war file and jar file for Java, right? These are your deployment artifacts. The beauty about these artifacts are this have something called as application and containers. So what it is, basically a package which has its own runtime. So it is very, very lightweight compared to the virtual machines. Now it gives you the freedom that you are able to scale. So on the same hardware, if you are able to run 2 virtual machines, basically 2 applications, you will be now able to run 5 applications. So what I'm trying to explain you is, as we have evolved, right? When we talk about advanced computing, our minds always think larger machines, larger compute power, larger storage power. But advanced computing, as I said, can mean many things. It could mean how you procure your systems. Obviously, it means how you have advanced in terms of how you build your CPUs and how powerful the CPUs are. But it also means how you deploy your applications, right? So the same hardware can now have considerable more number of applications it can deploy because of the advancement in the technology. So it is also a kind of advanced technology, right? Now, another thing I want to talk about very specifically is, so this container concept then also evolved into something called as Kubernetes. So you are seeing one machine here, right? Now, in production systems, people run thousands of machines. Let's say you are a large, just taking an example of the big billion sale of these large companies like Flipkart, right? So there is, you don't run those systems on one machine. You run them on a fleet of machines, right? So they run, assuming you're running all of those as containers, you don't run one application or one specific box. You will have thousands of such machines running as a group. So we have a concept called horizontal scaling and vertical scaling, right? So there are 2 ways. If you need more hardware, there are 2 ways you can have more hardware. The traditional way is just keep on increasing the CPU and memory of the machine, but it has a limit, right? You must have heard of Moore's law. After a point, you can't increase the compute capacity of a machine. There is a limit. The other way is to have more machines and then let them work together. That is the concept how Kubernetes work. That is the same concept on how Hadoop works. That is the same concept on distributed databases like Elastic and Mongo work. So that's the same concept. And just to prove that point, right? So we had so Google has a product called Kubernetes, which is providing the same container technology or Kubernetes technology on the cloud. And we had one of our customers, right, who was earlier using a supercomputer. Now, what they did was they procured compute on the cloud. Very specifically, they procured 180,000 instances on the cloud. Okay, which gave them a capacity of around, I think, 2.8 million virtual cores and 72 petaflops. So rather they then use, and they actually were using a supercomputer earlier. So what they did is, which is supercomputer are like the vertical machines I was talking about, right, where you increase the compute and storage, and they are very, very expensive. They were using a supercomputer. They basically replaced that supercomputer with a Kubernetes cluster, which had 180,000 nodes, which gave them a 2.8 million virtual core capacity and 72 petaflops of, I mean, that is the clock speed, so to speak. It is like 10 to the power of X. I don't know what that number is. But the important point here is it is equivalent to the 7th largest computer at that time. So my point is, again, when you talk about advanced computing, you talk about supercomputers, don't just think about you need more machine, more capacity. It's not a single machine. You can, with these advanced technologies, right, you can make the smaller machines, right, the 8 cores machine, the 16 core machine, and we call them commodity hardware. These smaller machines are called commodity because they are abundantly available in the market. So you can actually make commodity hardware behave like a supercomputer. So that's the whole idea. And as a startup, you can do it today. So you have that capacity available for you to consume, which you could never dream of earlier. So that is again the advancements we have made in terms of how we are deploying things and how the software has evolved, rather than the hardware being evolving. Now, finally, I mean, any conversation these days cannot be complete without talking about AI ML, right? So AI ML, you must have heard about things like AI ML, machine learning, neural networks, generative AI, and large language models, right? Again, these are advancements in how do we make decisions, right? So how we used to make decisions earlier was we used to write a lot of if then else conditions in our code. So if input is equal to this, do this. If input is equal to this, do this, so on and so forth. So the system can only answer on predictable questions, right? But then we had this concept of artificial intelligence coming in, which is a broad term, which basically means whenever a computer shows some intelligence, that is called artificial intelligence. Now, inside artificial intelligence, there is something called as machine learning. And what machine learning basically means is, can the machine learn through some algorithm? Can you teach the machine to learn? And one example is, let's say, through those algorithms, you will say, I have 100 pictures of a cat, right, or a dog. I will show 20 to the machine, saying that this is how our brain works, right? If you see 20 pictures of dog, if somebody shows me another picture of dog which I have not seen earlier, I can still say it's a dog because I know what features a dog has. It has a typical nose, the ears are upright, it has a tail, so on and so forth. So what machine learning basically is earlier, before the concept of machine learning, you can't do that, right? But now what you do is, in machine learning, the way this would work at a very high level is you will have pixels on the photo of a dog, right? And there will be a pattern, and the machine learns that pattern. So if you show them 20 pictures, from that pattern, it will be able to figure out any other dog picture that you show him. That is called machine learning. And how machine learning used to work is something called as a concept of neural network. So this is how even our brain works, right? There is an input and then there is output. So inputs are, in this case of a dog picture, could be the pixel, right? The number of pixels on the screen could be the initial neural network, and the final output is a Boolean saying whether it's a dog or not a dog. So, and in between there would be layers. So this layers, from the first layer to the last layer, where the machine is predicting whether it is a dog or not, is a network, and that network used to be called neural network at a very, very high level. Now, earlier what used to happen is, when you create these neural networks, you can only train them to do only one task. So, for example, find whether it is a cat, or find whether it is dog, find whether it is a human or not. From a text input, find whether this text is positive sentiment, negative sentiment. from this specific data, tell me what are my growth projections, so on and so forth. So they were trained to do only one task, because training these models was expensive. But what
Sir,
we
sorry
have
to
today,
disturb you.
yeah, ma'am.
I said there is a time limitation.
Okay, so this is my last slide, ma'am. I'll take 2 minutes. Okay, so what now we have is something called as large language models. So what we have done now is, through the advancement again in computing, we have created large language models. So these are large neural networks. So you have trained them on large set of data, and the way you have trained them is now they can do anything. So rather than having a single model to do a specific thing, now there is a large model. So you must have heard of ChatGPT, you must have heard of Bard from Google. So you are having these large models now, and they can do anything for you. Again, this is possible because of the advancement in computing, where we use a lot of GPUs and TPUs to basically essentially train these models on whatever data is available on the internet to do whatever task is available in the world. And that is again through large language models. And there is a branch of large language model called generative AI, which is more to generate output. So generate text, generate summaries, generate code, so on and so forth. But again, these are available for you to consume today. So I mean, the last thing I want to leave you with, right, is advanced computing, cloud computing, whatever you want to call it, right, is now democratized. If you have an idea, if you want to become an entrepreneur, right, you don't have to do a lot of investment. You can just go execute your idea, and then the sky is the limit for you. So that is what I want to leave you with, and that is all from my side. Thank you.
Thank you very much, sir, for sharing your expertise on cloud and cloud architecture. Before proceeding further, I would like to announce to the participant, please write queries in the question QA box. At the end of the session, the expert will take the queries.
Thanks. Is my screen unshared or it is still shared? I'm not sure.
Sir, it is unshared.
Okay, thank you.
A talk is a voyage with a purpose. The man who start out going nowhere generally reach to the success. It gives me immense pleasure to introduce the next eminent speaker of the session, Professor G.S. Tomar. Professor G.S. Tomar, Director, Government Engineering College, Sonbhadra, UP, India. Professor G.S. Tomar has led the Director of famous research lab, THDC, IHET at Tehri under Government of Uttarakhand for 3 years. This lab promoted by a group of technical teachers and researchers. It provides facility for young researchers free of charge, which includes software, hardware, and guidance by the senior professor connected to the labs from many countries. Professor G.S. Tomar has done his postdoctoral fellowship from School of Computing, University of Kent, UK, in the year 2012. Earlier, he had worked in MIT's Gwalior for almost 4.5 years. He has also worked as a principal at MITM Gwalior for 2 years. He was visiting professor at University of Kent for 1 year. He had also worked in the University of West Indies, St. Augustine campus in the Department of Electrical and Computer Engineering from August 2013 to June 2014. He has also served MPCTM as a professor and director for 3 years. Now I would like to invite Professor G.S. Tomar for sharing his wisdom of knowledge with all of us. Over to you, sir.
Thank you, ma'am. Thank you, ma'am. Just allow me to share the slides.
Yes, sir. Sir, one thing, sir, it's a request for you that there is a 25 minutes for the presentation.
Okay,
and
okay.
5 minutes.
It's good. It's
Okay.
good. It's good.
Okay, thank you, sir.
Just am I allowed to share?
Yes, sir.
Why it is not taken?
Yes, sir, now with
Okay. Is it visible now?
yes, sir.
Thank you, ma'am. And it's a proud privilege to be part of your conference. In fact, what we heard from just previous speaker, that nowadays the technology is moving very fast. Your computing is moving very fast. But how to communicate them? What is the mode of communication? So we need to think of that also. Because nowadays we have heard about 4G, 5G, and now the next version is also in pipeline. So just I'll be discussing about the future communication systems, which is generally referred as beyond 5G communication. Because already we are in era of 5G, but what was the proposal earlier for 5G has not yet met. So this is what we have. From where we started, it's in a late 80s, in fact, 1980s, then 1G, 2G, 3G. In fact, many service providers do not have even 4G as of now. But still, we need to talk about what is available to the world, and then how can we cope up the difficulties if there are any such services available to us. So what is the basics of these 5G systems? That we need to think of frequency, because this is what playing major role. You must have seen when you use your dish TV, when there is a sudden rain and your signal goes away. And no one thinks of what is the reason. Reason is that we are increasing the frequency. So same way when we talk about 5G and beyond 5G, if you go to that range of frequency, the same problem will arise for our mobile communication also. So we need to discuss and we need to think of that also. So what is presently used frequency is 3.4 and 3.8. This is a major band. Another band is 2.6 gigahertz. And I think everyone may be having in their household microwave oven. And what is frequency of operation? That is also 2.4 gigahertz. It means when we talk about the modern communication system, we need to think whether it will affect our environment or climate or human beings, animals. That is the last part which I'll be discussing. Just one slide I have prepared for that, because that is the major research which is going on around the world, because we are only users. In fact, we do not develop anything. We are just hiring and using. Especially when we talk about communication devices, at the most we are assembler. We will bring all components and then assemble here. So that is what, when we assemble, we need to, because we are from the engineering fraternity, so we need to know what are the pros and cons of technologies which is being used by us. So when we talk about any communication device, we need to just go from its basics to its application. So first is, what is the frequency band which is being used? So that is what, when we talk about the third line, if you see 26 gigahertz. When we talk about 26 gigahertz, then there are many problems in this band. That's why still it is not being used, but it is allotted for 5G and beyond 5G communication, especially for 6G it was planned, but there are some hiccups and many researchers have put up their reservations on this band. So basic features of 5G, if you see, more devices, because nowadays when we talk about IoT, you do not have any counting the devices. Number of devices are uncounted. So can we have connection between all those devices? Because when we go for wireless communications, then you need to either use, if it is a short distance, you can use Wi-Fi. But when it is a long distance, you have to go on some channel which is communicating far away. And when you talk about far away, it means you have to use cellular mobile communication. There are many users available. I think all are engineers or going to be engineers in audience, and they use a smartphone. Everyone is having a smartphone. Latest smartphones they will be having. But when I question, even in classes or anywhere, that how many networks you have in your smartphone, they do not know. There are many networks available in your small device, but they are not interconnected within the device. It means there may be certain technical flaws, or there is a lack of research where we are not able to interconnect one network to another network in the same device. It means when you have any connection between your cellular mobile and your Wi-Fi, your own Wi-Fi, you need to go out, then go to base station, then MFC, and then again come back to another station, and then you will be connected through some mobile devices and then internet. It means everyone wants to use this spectrum, then the requirement of data rate is very high. So in fourth generation, it was thought of having 10 Mbps, but we could go up to 10 Mbps. But in 5G, it is expected that it should go to Gbps, because when you have more and more data, then you need to have more and more bandwidth. When you have more and more bandwidth, it means the data rate for the devices which are being used should be compatible to that requirements. So if you see this entire slide, you will find what are the basic requirements and the features for 5G communication. So this just replica of that diagram which we just discussed. Then what is the architecture of 5G? If you just happen to see the 5G enabled device, it means the latest version of smartphones are also coming. If you take, I think 13 and above Apple, or I think 12 and above, they are 5G enabled devices. And Chinese, every device is 5G enabled, even if doesn't have capability of executing or the data rate which is required, but just they are enabled. But the best brand devices, if you take, and then if you want to have that device connected to every possible device having data processing capability or transmitting capabilities, and if you are able to connect, then I think you will be able to transmit whatever is required. So these 1, 2, 3, 4 figures are available, that S and 3G, WLAN, LTE. LTE you must have seen. If your 4G device is LTE enabled, then only it will be able to communicate on higher data rate. Otherwise, it will be below 1 Mbps. But if you want to connect this WLAN, WLAN is having different protocol and LTE is having different protocol. Still, there is a problem in 5G communication that you are not able to directly interface with WLAN. There are standards being designed, but it is under conception, and I think by next year you will be getting that standard. You may be knowing that all the standards are IEEE standards, and until unless it doesn't come as IEEE standards, you are not able to use it internationally. You can use in laboratories or any place if you have your own standard and want to have connection. But until unless it is not ratified by ISO and IEEE, it is not available to the world as standard or the international standard. So still you do not have this WLAN connection to directly your smartphone. LT is available, 3G is available. Then why you need? Because you need to have because just previous speaker who was talking about cloud computing, it means a lot of data available on cloud, and you want to navigate it to the users. Then you need certain channel. Channels are various channels. You have satellite channel, you have mobile communication channel, because satellite channel is not real time. But this 5G is near real time. Still, it is not real time. So what are the major concepts which make it real time? It is a delay and latency. So this 5G was thought of having latency less than 1 millisecond, but it couldn't have that till date. So these are the applications. Only one line, that's a third point you need to just discuss. Why it is so capable of having many devices connected to it, because it is using IPv6 in place of IPv4. So every computer engineer knows what is the difference between IPv4 and IPv6. So these devices are IPv6 enabled, but compatible to IPv4 also. So we need to know that whatever you are learning, or you are just going through the technologies, new technology in the computer science, it is not isolated until unless you are not connected with both the, in fact, the electronics engineer and computer engineers are not collaborating. Till then you won't have any device to be used by the world, because it has to be designed and then it has to be programmed. So when you program it, then there is a part of software, and that is the life. So when you use IPv6, the number of devices, and then further security reasons, so many features are inbuilt in these devices. When you have many and many features, it means complexity has to go on more, and it means that device will be more and more complex. So if you see, it need to have how much? That's a 1 to 10 Gbps, but practically still we are not able to get this 10 Gbps over 5G communication. So when you have some bottleneck, what is bottleneck? Bottleneck is always with the communication devices. Practically, if you see that mobile or the base stations or repeaters you may be having on your rooftop also. Now you just think of when you changed from 3G to 4G, did your rooftop antennas change? I don't think. Those towers are same, and the service provider says that we have changed from 4G to 5G. Until unless you do not have capability of all the communicating devices to transfer from, that is the baseband, to air. So in between you have many devices. The devices of amplification and then interfacing to antenna, and those interfaces are so costly. For your practical knowledge, if just you keep in mind that for 6G, still there is no connector available in the world. After 2 years, that standard will come up, and then only those connectors, without having any leakage and radiation, because when you pump the energy, it should not radiate before it goes to air. If that cable and connectors are not available, then how can you have that much bandwidth and then communication to the air? Still that 2855 standard is, that's the working group is under process. And after 2 years only, you will get those connecting devices. You may have amplifier, you may have antenna, but until unless you do not have connector in between, then how can you connect it? So still it is on paper, practically, but for commercial purpose, everything is available in the world. By having this 5G, especially 5G, it was thought of that it will be like Wi-Fi zone. Wi-Fi zone means you have a lot of bandwidth available to you, but still when you see practically how your Wi-Fi is working, you know it very well, because the basic problems are those interfaces and connectors. Now, these are, it can have more than 60,000 connections. It means your cell, one cell have, when you have 3G cell, it doesn't have more than 1,000 connections. It depends upon the capability. But in 5G, it was thought of that it will have at least 60,000, but actually you have practically you couldn't go more than 10,000. These case histories are available. You need to go through. So because time is very less, so I'll just go through a bit quickly, and I'll go to last slide, which is really the area of research for all engineers. Many challenges. So here, just this RIS assisted, reconfigurable intelligent surface assisted beyond 5G. This system is now being thought of for overcoming the challenges of 5G. But when we think of this, then what are the problems? I'll go to, this is what problem is. How it is affecting human, animal, and environment. Because along with engineering student or teacher or any working in industry, if we create any sort of device, we need to think of environment also. We need to think of various hazardous effects of that particular device. So when you use beyond 2.4 gigahertz frequency, it has to have some negative effect on everyone, which includes environment. So it is not that only that coal powerhouses are responsible for climate change and many problems in environment. These devices are also affecting that. Because once it can roast your food in microwave oven, if you do not use a standardized mobile repeaters, then it can roast nearby everything available nearby to that particular tower or particular device. So there are certain standards that beyond which there should not be any radiation, or that energy has to be constrained to that particular limit. But generally, that all low quality devices and unbranded transmitting devices do not consider the maximum limit available, which is beyond which it is harmful to animals, birds, and environment. So we need to go for this. In fact, being in our country, it is not a practice. Otherwise, whenever there is a problem, there are around 80 universities which have been given funding by various international industries. Because here, our industries, what they do, all industries, because they found that academic is very lucrative source of income. So those industries, leaving apart their own business, they will open their own universities. And those universities are not for research, but only for their own products. So that is what negative is. But around the world, if you see, all industries are funding the universities for such researches. So when you have any visit, so you need to visit here and there, and by which you will come to know that what is the real world of technology and how we can contribute to it. So there are many universities working on this. What is the effect of 2.4 gigahertz, what is the effect of 26 gigahertz, and what is the effect of 60 gigahertz. Because generally we use free band, so 60 gigahertz is also free band. And just you read, go to Google, many papers are available. When you use 60 gigahertz for communication, even it eats the oxygen of the environment. So if you use that frequency for your own use, because it's a freely available, then the contents of oxygen will also be reduced in the environment. So how it will affect, you know it very well. So it is like earlier our many grunts where we have that if you squeeze out oxygen, like Pavandev squeezes the oxygen, everyone is about to die. So that thing will happen. So we need to think of that also when we are working on certain research. So thank you very much, because we need to conclude in the time, and I think it's a 24th minute. So I really thank you, and if there is any discussion, I'm available. And because this is my area of research, especially this effect of these frequencies on environment and animal, so I'll be able to help researchers who are working in this. Thank you very much.
Thank you very much, sir, for sharing your expertise in 5G communication. Dear participant, if you have any query, you can write in the QA box. Okay. Now moving ahead, intelligent interaction and knowledge discovery has greatly broadened the scope of computing. This conference aims to bring together academician and industry person and researcher to share their more recent research and practical solution and experience about the trends, opportunity, and challenges in the area of intelligent interaction and knowledge discovery in the future-based advanced government. Now, I feel privileged and obliged with to introduce the third eminent speaker of the session, Mr. Rahul Amritrat Singh. Mr. Rahul Amritrat Singh, Head of Incubation at Government Institute of Medical Sciences, Greater Noida. He is currently Head of Incubation at Government Institute of Medical Sciences, Greater Noida. He is healthcare professional with rich academic background in dentistry, healthcare management, and health communication. He is passionate about medical innovation and incubation, and is currently serving as the Head of Incubation at the Center of GIMS Greater Noida. Mr. Rahul Amritrat Singh has a degree in dentistry and a master from prestigious FMS Delhi University, as well as PhD in management and expertise in health communication. He has received extensive training in oral cancer screening and has participated in numerous workshops and symposiums hosted by organizations such as WHO, FCTC, AIMS, ICMR, NICPR. Dr. Singh has presented his research work in cancer screening and early detection at the World Cancer Congress in 2018 and 20. He is also the founder director of Manavta Cancer Foundation, an organization dedicated to early cancer screening and detection. He has received NEDAR Award from He has received the NEDAR Award from Max Cancer Foundation and appreciation from the government of Mizoram for his work in cancer awareness. Now, I would like to invite Dr. Rahul Amritrat Singh for sharing his views with us. Over to you, sir. Over to you, sir. Sorry for technical glitch.
Sir message that he will join within 1 minute. There is some technical connection error. Please wait.
Okay, sorry for the technical glitch. Wait, you will wait for 5 minutes. Meanwhile, participant, if you have any queries, you can write in the QA box.
शादाब एक बार चेक करें अटेंडी में उन्होंने ज्वाइन कर रखा है उनको पैनलिस्ट में
यस सर अपने रिक्वेस्ट सेंड कर दी है सर
ठीक ठीक ओके
ओके
I request Mr. Rahul Amritan
Hi.
Singh, sir, to share our views with us.
am I audible
Yes, sir.
यस सर
So,
okay
the timing is limited, 20 minutes, and then
how much time do I have if at all you can just tell me I'll accordingly
sorry, thank you.
plan it
इट इज 25 मिनट्स सर
20 oh that's more than enough okay so just forgive me because I'm a practitioner I'm not that sound with technology so that is where my technology friends needs to help me okay so coming down to today's particular session so thank you for inviting me and giving me an opportunity to interact with this amazing audience so I'll be the entire 20-minute session would be divided into first 10 minutes about what is medical incubation, what all opportunities do we bring in the medical sector for other technology people, and then what are the challenges, and then in the last section of the discussion, I'll be talking about how one can plan a startup in the health domain, which happens to be one of the largest domain. So do I have the privilege of sharing the slides as well? Can I?
Yes, sir.
Okay. Perfect. Just a minute. So most of the audience that I'm talking to today is they're engineers, right?
Yes.
So it is really interesting to interact with people who are deciding everything these days, right? From the invention of CT MRI to the invention of AI, ChatGPT. So, the entire world revolves around the invention that you guys do, right? And then probably in the session, I'll be talking about the contribution that engineers have made into the healthcare sector and how healthcare sector happens to be one of the most promising in terms of startups, in terms of a good career, and everything around that you want to know. So I'll try to just a minute. So my slides are visible, ma'am?
No, sir.
No, sir.
Okay. So slide share. Okay, here share. Is it visible now?
Yes, sir. Now it says.
Is it visible? Is it visible now?
Not visible.
If somebody can tell me if the slides are visible.
Sir, not visible.
Actually, right now it is not visible, I think due to connection delay. So you may continue without sharing your presentation.
Yeah, that's totally okay. Okay, so I come from this government medical college, which is in Greater Noida, and we're called GIMS, Government Institute of Medical Sciences, and we have the state's first public hospital-based incubation system. Incubation system. What happens into a hospital-based incubation system is like the hospital has an incubator, and for example, whatever inventions that you do into technology, and if at all you're inventing something for healthcare, there needs to be a validation of the device, validation of the product. And that comes in picture where the device that you have made with technology needs to be tested over patients. That is where we, as a help you out with the clinical trial, right? For example, I'll tell you 2-3 examples. The inventions that have been done into the medical sector and opportunities that we bring. An engineering graduate from Kolkata, he was not aware of the periods, and period happens to be a big taboo. When he got to know about the periods from his own sister, that there is a terrible pain in period, and the options that are available in the market are painkillers, hot water bags, and not more options. He thought of why does the pain happen? And then when he got to know that there is a Gates theory of pain, and this Gates theory of pain is the reason behind the brain feeling the pain, he's the first man on the earth. He has invented a device. He has invented a device that reduces pain during periods. An engineering graduate comes down to a medical school. He learns the mechanism of pain. And then this device which he has developed is a non-invasive. Like you have to wear it on the abdomen. There's a frequency meter. You have to set the frequency. And the pain which the brain feels, this particular device which he has made generates an impulse which neutralizes the pain that the brain feels. So these sort of opportunities, that is where we invite people, your technology and your intervention into healthcare can turn around things for people in the world. This is one of the examples. For people coming out from hardcore engineering background, I'll tell you, we have one more startup. There's a replacement for sanitary pad. There's something called menstrual cups. These menstrual cups can be reused. And then the problem with this menstrual cup is these are very, very costly. So everybody cannot afford it. So the technology has to be cost effective so that everybody uses it.
So your
These
slide-
guys have come down to our.
So your
these
slides is now
guys-
visible. Sorry to
Yes,
disturb
ma'am.
your slides are visible now.
Okay,
Your
okay,
screen is
okay.
visible now.
Yeah, sure. Thank you. So these guys who have come down to us, now they want to design a menstrual cup for Indian population where the silicon grade medical material is made of such quality that it is very cost effective and that everybody can use it. We have a startup. He is making sanitary pads which has got bioplastic, because in most of the sanitary pads that you see these days, they have got the outer layer as plastic. So there are n number of things happening into health domain. We have a startup. He's working on mental health. What happens is he has an application. This application, one needs to speak to this application for 7 to 8 days. This particular application, which is trained with AI and machine learning, depicts your behavior in 7 to 10 days. And this helps people with depression, with loneliness, to figure out the problem that they have. When they came down to our medical college, they were recording all the voices. As engineers, they had this knowledge that, whatever data that we feed into the machine, that's okay. But then again, faculty sitting here will always agree with me. It is all about not the data. It is all about the quality of data. When they came down to our medical school, we very clearly said, you cannot technically or legally record anybody's conversation, like me and my patient. I cannot record the conversation of my patient without the consent of my patient. And then voice is a biological sample. That is where we tell people, we as a medical school, we have our own responsibilities to tell the technology friends that you cannot just record anything because it is available. You have to check out whether this is a biological data or this requires some approval. This has some a different technical aspects of it. One gentleman, what he has developed is, people must resonate on this. There's a medical condition called Alzheimer. In Alzheimer, the patient tends to forget things. Now the problem is, this little boy who comes from a very small city in Bihar earns a very little in Delhi, and he has no option of going back home. His mother is an Alzheimer patient. वो भूल जाती है कि हम दवाइयां कितने बजे हमें लेना है, कोई mechanism नहीं है, not married. He develops a hardware. अगर if at all this is the bottle, he develops a hardware onto the top of the bottle. This hardware can be connected with the Wi-Fi, and it has a space where he can keep medicines. And this, whenever the dose is required, there is an automation done that the medicine will fall into the particular bottle. And once the medicine falls into the bottle will start resonating or will start producing a sound and will not stop till the time the medicine is taken out of the box. So technologies needs to be, technology needs to solve a bigger problem. And we always say this, whenever there is a larger problem, bigger problem, higher is the opportunity to develop a startup. My friends out there, you must agree to this. When COVID came into picture, the only possible test was RT-PCR. And RT-PCR took around 6 to 7 days in the initial days to come out with the result. Very few centers had RT-PCR. This, one of the biggest global problem, one of the startup in Pune, my lab, came down with one of the world's first antigen kit. This was nothing but innovation. So the bigger is the problem, the larger and the higher chances of making a bigger startup or a successful startup you have. Nobody thought that antigen kit would be available just 100 meters from your own space. So this development of antigen kit was one of the remarkable inventions that came into the world. Second, most of the vaccines, they take around 15 to 20 years to develop for a particular disease. COVID vaccines came to the world in 1.5 years. So bigger is the problem, bigger is the market, and then bigger are the chances of creating a high impact startup. Into health and into a country like ours, where the population is our strength and population is our problem as well. For anybody to make a startup into health is one of the best choices that one can make. And the way things are changing the world, non-invasive pathology is the new world. Artificial intelligence and machine learning into radiology is new world. Robotic engineering into surgery is new world. Generation of entire tooth with a stem cell is new world. Everything is happening around this. So my friends out there who are working with the core domain of engineering, this is an era of collaboration. This is an era of interdisciplinary approach. We need to collaborate. We need to talk to our friends into other domain, look for possibilities, find our co-founders. You should not think about the funding. Funding comes at a later stage. Into today's world, into every state wherever you are, the mechanism and the ecosystem to promote startup is working onto a very different potential. The entire intent is to tell you, like, this is so amazing. We have got a startup. All the 3 founders are female founders. These are all CSIT engineering graduates. They tell me that, we do not go to bed if you do not, we do not get the sleep if we don't code. And they have invented one of the most amazing things in the world. These DICOM images of CT and MRI turns around into a 3D image in the OT. Engineering people have got the magical power to convert things that we do not even think or imagine with naked eyes or with the possibilities that we have. So we need more and more of people to come down to health sector, and then institution like ours, which are medical incubator. We are the only after AIMS is number 1, and then we are the number 2 here. Public hospital-based incubator. Our strength is, if you have a device, you have a solution for diabetes, you have a solution for the specs that I wear, you have a device which cures type 1 diabetes. If you have an idea which you believe that the radiation that we are giving the cancer patient can be with a lower dose and high impact, a number of things. The right application of what you've studied in the school and high volume impact of that study comes out in the startup domain. Our engineering graduate in Goa Institute of Management has developed a device, not a chewing gum. Tuberculosis happens to be one of the biggest problem of India. And the government has all its plan to fight TB like anything. We are not able to contain TB because TB spreads very fast. Something like COVID. Not as like COVID, but something like COVID. Because during COVID, TB came down a bit because people were wearing masks. Problem is, the only way to test TB is, there are just 2 methods. One is a Montauk's test, that you put an injection in the skin and wait for 24 hours. Other is a sputum test. This biomedical engineer in Goa has developed a chewing gum. If the community is given a chewing gum and they chew the chewing gum for 10 minutes, if the patient has tuberculosis, the color of the chewing gum is going to change. This is innovation. That is where interdisciplinary people need to come together and create something new. There's a lot of possibility, a lot of opportunities, and forums like this needs to share opportunities with everyone. So without taking much time, I'll just share the how do you plan for a startup? Probably last 5 minutes. First of all, figure out the problem around you. Bigger is the problem, bigger are the chances that you have a huge market. So there's always a plan to go with. Plan out 4 or 5 problems and then figure out, are they actual problems? So do a due diligence of the problem. How big is the problem? And then the solutions that you're giving to this problem, how unique is it? Are you helping with some technology? Once you have this uniqueness in solving the problem, that is called a startup. Conventional businesses are not startups. Starting 10 particular grocery shops are not startups. कुछ नयापन होना जरूरी है. किसी एक बड़ी प्रॉब्लम को एक नए तरीके से सॉल्व करने का जो हमारा तरीका है ना, वही एक नए स्टार्टअप को इजाद करता है. और जितनी बड़ी प्रॉब्लम है, हमेशा यही फिगर आउट करें कि एक बड़ा स्टार्टअप कैसे बनेगा. There's a very small story. जो ओला के ओनर हैं, जब उन्होंने प्लान किया कि हमें ओला स्टार्ट करनी है, और ये आपको सबको आश्चर्य होगा जानकर, सबसे पहले ओला वाज अ होटल कंपनी. दिल्ली की सड़कों पर वो दिन भर पैम्पलेट लेकर लोगों को पैम्पलेट दे रहे थे जब कॉमनवेल्थ गेम चल रहा था. और पूरे दिन, वो अपनी स्टोरी में कहते हैं कि पूरे दिन जब मैंने लोगों को पैम्पलेट दिए, मुझसे सब लोगों ने पूछा कि यार यहाँ से मुझे मेरठ जाना है, गाड़ी कहाँ मिलेगी, मुझे यहाँ से आगरा जाना है, मुझे गाड़ी कहाँ मिलेगी. देन ही रियलाइज कि मैं तो होटल बेच रहा हूँ, लोग मुझसे गाड़ियों के बारे में पूछ रहे हैं. दैट इज वेयर ही स्विच्ड हिज आइडिया. कुछ गाड़ी वालों से उन्होंने बात करी, गाड़ियां खरीदी नहीं, एग्रीगेटर बने. एंड दैट इज हाउ ओला केम इनटू शेप. इसीलिए ये जरूरी नहीं कि आपका पहला आइडिया बहुत जबरदस्त हो. इसलिए एक मार्केट सर्वे बहुत इंपॉर्टेंट है किसी भी प्रॉब्लम का. हाउ बिग इज द प्रॉब्लम एंड इज द प्रॉब्लम रियली बिग, ये सिर्फ आपको लगता है. और इसी तरह की प्रॉब्लम के या आपके प्रॉब्लम को और शार्प कर देते हैं. फिर तय करना होता है कि मेरा को फाउंडर कौन होगा. को फाउंडर वही होगा जो आपसे अलग हो थोड़ा और किसी एक टेक्नोलॉजी में महारत हासिल करता हो. अगर आप CS के हैं और दूसरा बंदा आपको लगता है कि मुझे प्रोडक्ट डिजाइनिंग का चाहिए और वो मैकेनिकल का मिल जाए, अलग अलग स्किल सेट के लोग जब एक साथ आते हैं तो वो एक अच्छी टीम बनाते हैं. बहुत जरूरी है प्रॉब्लम आइडेंटिफाई करना, अच्छी टीम बनाना और अच्छी टीम के साथ अच्छी मेंटरिंग. और ये सारी चीजें आपको मिलती है इंक्यूबेशन सेंटर में. मुझे उम्मीद है कि आपके यहाँ भी इंस्टीट्यूशनल इनोवेशन काउंसिल होगा. वो एक छोटा फॉर्मेट है इंक्यूबेशन सेंटर का. और फिर ऑलमोस्ट सारे ही जगह आपको इंक्यूबेशन सेंटर्स अवेलेबल है. और सबसे इंटरेस्टिंग बात यह है, ये जरूरी नहीं कि आप अपने डोमेन में काम करें. आप इंजीनियर हैं, आप हेल्थ टेक्नोलॉजी में, आप एक ऐसा शॉट बना सकते हैं जो टेम्परेचर के हिसाब से कॉर्नर का कलर चेंज होता हो. आप एक ऐसा ग्लास बना सकते हैं कि अगर इसमें दूध डाला और दूध गर्म है तो 30 डिग्री पे इसका कलर कुछ और होगा, 20 डिग्री पे कुछ और 10 डिग्री पे कुछ और. सो दैट कि अगर बच्चा इसको पिए तो पता चले कि जब ये ब्लू है तो मैं पी लूं. टेक्नोलॉजी को इस लेवल पर यूज करना है कि वो इंसान की एक बड़ी प्रॉब्लम को सॉल्व कर रहा है. एंड दैट इज हाउ हमारे इंक्यूबेशन सेंटर में वी आर इंक्यूबेटिंग ओनली दो स्टार्टअप्स जिनका बहुत अच्छा इंपैक्ट हो रहा है. अभी हमारे पास ड्रोन टेक्नोलॉजी में लोग आए हैं जो एक हॉस्पिटल से दूसरे हॉस्पिटल के बीच में ब्लड की डिलीवरी ड्रोन के थ्रू करा रहे हैं. यहाँ से आगरा महज 250 किलोमीटर है. और जब हम बाय रोड टीबी के सैंपल भेज रहे होते हैं, एक टीबी होती है MDR, मल्टी ड्रग रेजिस्टेंट टीबी, वो लैब उधर है. जब हम भेज रहे होते हैं तो अमूमन 6-7 घंटे का टाइम लगता है. ड्रोन के साथ ये डिस्टेंस सिर्फ 2.5 घंटे में पूरा हो रहा है. बहुत सारी अपॉर्चुनिटीज हैं. एक्सप्लोर अपॉर्चुनिटीज, दैट्स द ओनली मैसेज आई हैव. हेल्थ केयर आपकी स्वागत के लिए बैठा हुआ है. अगर आपके पास एक दमदार सॉल्यूशन है, वो सॉल्यूशन कुछ भी हो सकता है. जो मैंने आपको एग्जांपल्स दिए, सैनिटरी पैड के प्लास्टिक को चेंज करके बायोप्लास्टिक लगा देना, ये अपने आप में एक इनोवेशन है. तमाम सारी अपॉर्चुनिटीज हैं. जरूरी नहीं, अपने एक किसी स्किल पे बहुत भरोसा दिखाइए. और ये वो डिवाइस है जो अगर आप देख पा रहे हो, ये मुझे लगता है कि इस तरह के इन्वेंशन की बहुत ज्यादा जरूरत है. और इस तरह के इन्वेंशंस आते हैं इंजीनियरिंग इंस्टीट्यूशन से. जब हमारे इंजीनियरिंग के दोस्त हेल्थ केयर में कुछ मैजिकल कुछ करना चाहते हैं तो इस तरह का सॉल्यूशन निकल कर आता है। मैं बहुत सारा वक्त नहीं लूंगा एंड if at all you have any questions to ask, I am open for it. Thank you very much.
Thank you very much, sir, for your knowledgeable insight on medical and healthcare management startups and its technical challenges and research opportunities. Now, with no further delay, I would like to invite respected session chair, Dr. Saurabh Jain, Professor of Computer Application and Head of Center of Excellence in Data Science, for the concluding remarks for the second plenary session of Avdharan 2023.
Thank you, madam. Am I audible?
Yes, sir.
So, a very good afternoon to chair of this session, Dr. Santosh madam, chairperson of Avdharan, Dr. Anand Rajavat, convener of this conference, Dr. Jigyasu Dubey, speakers of this session, Mr. Mohit Patiala, Professor G.S. Tomar, and Mr. Rahul Amritsar Singh, Dr. Arvind Singh, Joint Registrar, Dr. Sonika Srivastav. First of all, I would like to say thank you to team Avdharan for inviting me as a session co-chair in this session. So the first session, the first speaker of this session was Mr. Mohit Patiala on evaluation of computing. So he started this session with a brief introduction to advanced computing, exponential growth of Indian startup ecosystem from 2015 to 2022 in terms of startups, inventors, and incubators. He gave an idea about how to procure infrastructure using cloud computing. He also gave a brief introduction to cloud computing, including storage, networking, data, and other services provided by cloud. He also gave the examples of Ola and Uber and very well explained how we are using computing facility for getting routine services without owning the resources. He also explained about the evolution of deployment model of cloud from traditional deployment to virtualized deployment and finally to container-based deployment. Finally, the use of AI, machine learning, artificial neural network, and deep learning in decision making through machines. The next speaker of this session was Professor G.S. Tomar on the topic communication systems beyond 5G. He started with a brief introduction to 5G frequency, which ranges from 3.4 to 3.8 gigahertz band, its advantages, potential features capable of solving many planetary life problems, its ultra high speed, basic features of 5G like speed up to 10 Gbps. It supports wide range of applications, faster response time, and there are many more. After that, he explained architecture of 5G, applications of 5G like in mobile phones. Its advanced features like latency will be minimized, feasibility to connect 10 to 100 devices, worldwide coverage, reduction in network energy usage, and increased battery life, etc. Also, he explained the advantages that we will get from 5G technology and also the challenges in the implementation of it. He also briefed its bad impact on human, animals, and the environment. The last speaker of this session is Mr. Rahul Amritsar Singh on the topic medical startups. He explained the use of technology to invent the necessary devices or equipments which are very much useful for common people and which are very cost effective, like sanitary pads. Use of AI and machine learning to figure out the medical problems is very much interesting topic that is already we are using in many medical sectors. He also gave an example of antigen kit, which is a replacement of RT-PCR, is a typical example of use of technology which has reduced the time of report generation of COVID-19 test. He also believed the use of robotics engineering in surgery. Nowadays, there are n number of devices that are using technology to reduce the complexity in the treatment of diseases like tuberculosis, cancer, diabetes, etc. There is a lot of possibility by the use of technology for opening medical startups. Overall, this was very informative and knowledge-provoking session. All the speakers have very well explained their topics, and all these were in line with the theme of the conference. I hope we will have another association in the near future. Thank you.
Thank you very much, sir, for concluding the key insights of the session. With this, we came to an end of plenary session 2 of Avdharan 2023, a conference on intelligent interaction and knowledge discovery in future-based advanced computing. At the end, I extend my sincere vote of thanks to Honorable Vice Chancellor Dr. Upinder Dar, Conference Chairperson, respected Anand Rajawat, Conference Convener Dr. Jigyasu Dubey, Conference Co-Convener Dr. Abhishek Singh Rathore, for providing us such a wonderful platform to share our knowledge. I extend my sincere thanks to respected session chair, Dr. Santosh Dhar and Dr. Saurabh Jain for supporting us. And also pay my sincere thanks to distinguished speaker for sharing deep knowledge with us. And great thanks to all organizing team and technical team of Avdharan 2023 for providing proper support. Thanks to all participants for patient listening and making this plenary session and the conference a grand success. At the end, I would like to announce to the participants to please join the technical session 4 and 5 at sharp 1 p.m. today. Thank you all.
Thank you, Dr. Rahul. Thank you, Mohit sir.
Thank you. Thank you so much.
Thank you, ma'am. Thank you, everyone.
Thank you, ma'am. Thank you, Saurabh ji. Thank you, Rahul ji. Thank you, Mohit ji. Thank you very much.
Thank you.
Thank you. Thank you so much.
Thank you, Arvind ji, for joining us.
Thank you. Thank you so much.
Thank you so much, sir.